Hi, it's Mr. Barr, and these are the notes for Pythagorean theorem. Let's get started. So our goal, I can use the Pythagorean theorem to solve real-life problems. Why? Because I want to be able to find the distance between objects, which is one of the main things Pythagorean can do for us. So who is this guy? Pythagorean. Actually, his name was Pythagoras. He lived from 570 to 495 BC. Pythagoras was a Greek philosopher and mathematician. He came up with the Pythagorean theorem. This is one of the most important things you're going to learn in this class. The Pythagorean theorem can be used in construction, computers, engineering, and other places. So this is one of the more important things from this class. So let's start with, what is a right triangle? A right triangle is a triangle with a 90-degree right angle. And yes, that E got cut off right there. So these are all examples of right triangles. And so how do I know they're right triangles? Well, what I'm looking at is the fact that there's a right angle on each of these. So if I look at, where am I? So if I come over to this one right here, there's a right angle right there. There's a right angle right there. There's a right angle right there. And there's a right angle right there. So these all are right triangles because they all have right angles on them. So the Pythagorean theorem only works with right triangles. So what you're about to learn will only work with right triangles. So let's get started on these notes. So let's go with, start by putting your name on the notes. There we go. And we're going to start labeling the different parts of a right triangle. So start with your name. And our topic for today is the Pythagorean theorem. And we're going to start by drawing a right triangle. Let's put a couple things in this. Pythagorean theorem only works with right triangles. So notice there are three sides to the triangle. This side right here and this side right here are both called legs. And the biggest side, the longest side, this is always going to be the longest side, the one opposite the right angle, the 90-degree angle. This side is called the hypotenuse. So I have a leg, leg, and a hypotenuse. Leg, leg, hypotenuse. Since you're watching this video, we're going to skip this slide. But here is the Pythagorean theorem. If I have any two sides, I can find the third side using this theorem. So here's what it looks like we're going to do with a 9-12 triangle. So let's get this into our notes. A 9-12 triangle. So notice I have a side that's 9, a side that's 12, and I want to find that missing side. Well, that's what Pythagorean theorem will let us do. So this is what the Pythagorean theorem looks like. It's leg squared plus leg squared equals the hypotenuse squared. Leg squared plus leg squared equals hypotenuse squared. You're also going to see it written as a squared plus b squared equals c squared. Other classes will write it like that. So 9 squared plus 12 squared is going to be whatever that guy is squared. 9 squared plus 12 squared equals some other number squared. 81 plus 144 equals some other number squared. This adds up to 225. 225 equals some other number squared. And what is that other number? It's 15. So for the Pythagorean theorem, this number squared plus that number squared is always going to equal that number squared. This assumes that it's a right triangle. Let's put a right triangle symbol on that. And if I have any two of the sides, if I have a leg and a leg, I can find the hypotenuse. If I have a leg and a hypotenuse, I can find the missing leg. As long as I have two of the parts, I can find the third part. If you have any two measurements, you can find the third. All right, so we're going to do a quick tree map. So here's our tree map that we're about to build. So let's start with if we have a leg and a leg. So if I have a leg and a leg, this is what I would have. I'd have something that looks like this. And what I'm going to do is I call this square, square, add. I square this number and I square this number and I add them together. So square, square, add. Which looks like this. It looks like 3 squared which is 9 plus 16, which is 25. Now, is this 25? Is that 25 right there? No, that's way too big. So this is not the length of that side. I need to make it smaller. I need to take it down. I need to take the square root of it. Square root of 25. And the answer, and I just went off my page, is 5. So that's how I do it. If I have a leg and a leg, I do a square, square, add, and then I take the square root. If I have a leg and a hypotenuse, here's an example of a leg and a hypotenuse. If I have a leg and a hypotenuse, I'm going to do a square-square subtract. Which makes sense. I already have the biggest side. I have to get myself down to a smaller side. So subtraction gets me to a smaller number. So I'm going to go 10 squared minus 6 squared, which is 100 minus 36, which is 64. Is this 64? No, it's way too big. So I have to take the square root of 64 to bring it down to 8. So those are the two things we're going to be doing today. We're going to be doing a square-square add or a square-square subtract. So those are the two examples. I think we're pretty much done with the notes. So let's do some sample problems. Yeah, let's see. Let me see what my notes look like. Yeah. All right. So let's do this one. I'm done with my notes, but we'll do this one for practice. Let's see. So this one, I have the hypotenuse. So I'm going to do a square-square. Is this working? There we go. A square-square. Okay, so I'm going to do I guess I'm not going to do that. Okay, it's going to be a 15 squared. So I do 15 squared plus 8 squared. So 15 squared is 225. 8 squared is 64. I add those two numbers together, which gives me something with a 9 in it. What's that, 289? I am using a calculator. You can use a calculator also. That takes me to 289. And then I'm going to take the square root of that, and that's going to take me down to 17. And the next one I'll just do in my notes, or my notebook. Okay, that's how that works. So 17. This time we're going to do a square-square subtract. Actually, this is the exact one we did on our notes, isn't it? So square-square subtract. So I'm going to have 10 squared. Ooh. Yeah, I'm using my mouse to draw. It's not that great. My drawing tablet needs to be charged. Minus 6 squared. So that takes me to 100. Minus 36. Which takes me to 64, which is too big. So I take the square root of that, which takes me down to an 8. And there's the 8. 100 minus 36, 64. Take the square root of it, takes you down to an 8. Okay, let's do this one. Notice I'm looking for the big side. I'm looking for a hypotenuse. I have a leg and a leg, so this is going to be a square-square add. Okay, square-square add. So it's going to be 8 squared, which is 64, plus 6 squared, which is 36. Add them together, I get 100. Take the square root of that, I get 10. All right, this one I have the hypotenuse, so I have the big side. I'm looking for a leg, so this is going to be a square-square subtract. 17 squared is, what's that, 289? Minus 15 squared, which is 225 Subtracting those, I get a 64. Take the square root of that. I get an 8, which means this side over here is an 8. Because that was a square, square, subtract. Ooh, now we're getting up to some bigger numbers. Definitely going to use a calculator here. This is I have 2 legs, so it's going to be a square, square, add. So I need 32 squared. Using a calculator, that gives me 1,024. Plus 24 squared gives me 576. Adding those numbers together, I get 1,600. Taking the square root of that, I get, is that 40? That looks good. All right, I have the hypotenuse, so this, and I'm looking for a leg, so this is going to be a square, square, subtract. So 45 squared. That takes me to 2,025. Minus 36 squared. 1,296. Subtracting those two numbers takes me to 729. Taking the square root of that takes me to 27. So this side right here is 27. And here's our last one. Okay, 7 squared minus 6 squared. So this is going to be 49 minus 36, which is going to take me to 13. You can use my calculator. Square root of 13 is, I've got it as 3.61. I don't know what kind of rounding I expected on this, but so 3.6 or 3.61 depending on the rounding. 3.6. Yes, we had to round it. All right, hey, thanks for watching and have a great day. Bye.